In this video, we're going to be going over the real number system and how to classify real numbers. So the real numbers are the set of numbers that contain all rational and irrational numbers. So irrational numbers, these are numbers that never terminate, means they never end. If I can get this to type, there we go. And they never repeat. So it's a decimal that never ends and it never repeats. So some examples of that would be pi. So we talked about that in class already. So pi would be 1. You can also have the square root of any non-perfect square. That would give you a decimal that doesn't end and doesn't repeat. So rational numbers are the opposite of this. So rational numbers can be written as a fraction. Irrational numbers cannot. So these are decimals that terminate or they end, or it has repetition. So some examples of that would be 5/7, -3, 0, 20/5, the square root of 25. So within rational numbers, you have smaller, what are called subsets or smaller groups. The first one of those would be integers. So these are your positive and negative whole numbers. The next smallest group would be whole numbers. So these are numbers that start at 0 and go on in a positive direction forever. Natural numbers, these are your counting numbers. So when you first learned how to count, you started with 1. And these numbers also start at 1 and go in a positive direction forever. So if you were to organize these in a Venn diagram, so you have this larger group here, the real numbers, and within that you've got two groups, the irrational numbers and the rational numbers. And within the rational numbers, you have those smaller subsets. You have the integers, the whole numbers, and the natural numbers. So we're going to work through some examples. I am going to do the odd numbered ones. You're going to do the even. So this is asking us to name all the sets to which each number belongs. So we've got, for the first one, -47. -47 is a rational number. It's also a real number. If it's rational, it's got to be real. And it's also an integer. And that is all the sets this number could belong to. Now you've got the absolute value of -9. Absolute value of -9 is 9. So 9 is a real number. It's a rational number. It's an integer. It's also a whole number, and it's also a natural number. So it fits into all of those categories. For 5, I've been given a decimal that ends. So if you've been given a terminating decimal, it's a real number, and it is a rational number. And those are the only two groups that that number could belong to. For 7, it's asking for the negative square root of 64. So the square root of 64 is 8. Negative square root of that is negative 8. So this number is a real number. It's a rational number. It is an integer, but it's not whole or natural because it's a negative number. So these are the three groups that number can belong to. For number 9, I've been given negative 24 over 6. So negative 24 over 6 can be simplified to 4. This is going to be a negative 4. So it is going to belong to the same groups as the previous one, number 7. It's a real number. It's a rational number. And it's an integer. Alright, for this last example, this wants us to place the letter of the values to the left in the smallest set that contains the value. So the most specific group that that number could belong to. So this is asking for the negative square root of 50. 50 is not a perfect square. It is irrational. So I'm going to write the letter A here. Let's see, for C, we're given the number 8. 8 is a rational number. It's also an integer. It's also a whole number. It's also a natural number. So the smallest group that this could belong to is natural. For E, we've been given negative 4 1/5. Anytime I have a fraction, it is just going to be a rational number. So negative 4 1/5 is going to go there. I should have put the letter. Alright, so E goes here. G, we've been given 1.7 with a repeating 7. So because that 7 repeats, it can be represented as a fraction. So that would go with a rational number. That's supposed to be a G. The square root of 0. So what happens if you take the square root of 0? You get 0. So 0 is a rational number. It is an integer. It's also a whole number, but it's not natural. So whole number is the smallest group that can belong to. 3 to the negative first power. So let's put that into Desmos. If you're ever not sure about what some of these numbers are, put them into Desmos and see what you get. So this gives us a repeating 0.333. The 3 is repeating. So 1/3. So because I have a repeating decimal, it is a rational number. It can be represented as a fraction. And now I've got 7 times 10 to the negative second power. So Desmos will not do a negative power like this. So you're going to have to move the decimal 2 places to the left. So I have 7. My decimal's here. 1, 2. So I've got 0.07. And that is a rational number.